Hi, so my name is Andrew Coleman. So I work for IBM. I'm based down at the IBM Development Labs in Hursley, down in Hampshire. And the product area I work on is integration of applications, of services. And the challenge there is that the things we're integrating have no knowledge of each other. They could be legacy applications or new REST services. And they don't know they're talking to each other. And they were never designed to talk to each other, so their data formats that they understand are generally completely incompatible. So the integration product in the middle has to be able to speak lots of different transports and data formats, and to transform these data formats such that you can grab data out of one system and put it into another. And my area of specialization over the last few years has been this data transformation. So let's talk about JSON. So JSON is my current area of focus. So JSON's a very lightweight format. It's very easy to describe. It's just got numbers and strings and booleans and a couple of simple structures, arrays and objects, these associative arrays. But the challenge with JSON is that it's very simple on one hand, but also you can build very complex structures out of it because it's fully composable. So you can build these deep hierarchies of data. And so on the face of it, it seems really simple, but when you actually get sample data out of different systems, the fact that they all speak JSON, again, doesn't really help you much because they're all wildly different formats. And so there's a challenge for doing not just extracting the data that you're seeing, but also transforming so you can pass to another system. Now we're all JavaScript programmers, so it's bread and butter to us just to take some JSON data and to write a JavaScript program in order to traverse that, in order to pick out the interesting bits of data that we want. When you think about it, there's a lot involved in just doing that simple task. We obviously think about algorithms, and we have to set up loops perhaps and do if-then conditional processing. We've got to check data types, and then we've got to do lots of error checking as well if we want to make this a robust bit of code. So we're going to spend a lot of time just doing something that's actually, on the face of it, quite a simple task. And we're programmers. We're locking out all of these people who are perfectly technical computer users, but they can't get at this data within the JSON format, or any other format for that matter, because of this problem, whereby you've got to do all this navigation and querying in code. Now, this isn't a new problem. So if we go back to the 1970s, anyone remember the 1970s? No, neither do I. But apparently, back in the 1970s, the relational database was invented. And, this was great. All this data was suddenly being stuffed into tables and rows and columns. And the problem with that was all of this data was now only accessible to the IT people who understood how to program and access data out of these newly fangled relational databases. Again, the people who really cared about the data, maybe the business people, they couldn't get at it because they didn't have these programming skills. And then SQL was invented. So SQL, the structured query language, was invented that suddenly made this data accessible to a much wider audience. You've got these, reasonably competent computer users who are not programmers necessarily, could now access all of this data. So what is it about SQL that made the difference, that made it accessible to this wider audience? Well, the difference is that it was a declarative language. Okay, now what do I mean by a declarative language? It's a language where you still have a syntax to learn, but you take that syntax and you use it to describe the result, okay? Rather than describing the steps that a computer has to take in order to get that result. That's the fundamental difference with a declarative language. And users could really get their heads around that, the idea of describing the result, rather than having to implement an algorithm and do error checking and all those other hideous things that we do all the time. So roll on another 2 decades and XML became popular. And the World Wide Web Consortium quickly realized that they need to standardize another declarative syntax in order to make this XML data accessible to a much wider audience and also much simpler to access for programmers. And so that was the origins of XPath and XSLT and later XQuery. Okay, so I think we're at that point now with JSON. We've got so much JSON data now flooding across our networks, through your REST APIs and IoT devices and various other things. And I think we're spending too much time and effort in getting at the interesting data within this JSON. And also we're locking out the non-programmers who, really deserve a chance of getting this data themselves. And I think what we need is a declarative syntax like XPath, learn from the heritage that SQL through to XPath, XQuery has developed, okay, but apply that to this nice, lightweight data format of JSON. Now I need that actually today in my day job. Okay, so at the moment my colleagues and I are building a graphical data mapper in order to allow users to do integration between these various REST services, okay, in a graphical manner. Now we're aiming this system at non-programmers. They're technical people, they're people who would use Excel on a daily basis, so they understand, writing scripts, expressions, things like that. But they're not hardcore programmers. So we've created a declarative language for doing just that, JSONata. And it borrows very heavily from the heritage of XPath, XQuery. So my other job, by the way, is that I chair the W3C XML query working group. So that's the standards committee that produced the XPath and the XQuery specifications. And that work's still going on. So the first XPath spec came out 18 years ago. Okay, the latest XPath XQuery spec, version 3.1, just went to recommendation 4 weeks ago. Okay, so 18 years on, we're still adding into that specification. We're still learning the best practices for doing this declarative syntax. And I want to take all of that experience, okay, that we've learned from developing XPath and XQuery and apply it to JSON. So here we have JSONata, okay. Now, you've probably noticed by now I haven't prepared any slides for this talk, okay. I was just going to do a show and tell and demonstrate this stuff running, okay, and I'll take requests. So what I'm going to do is I'm going to go off and play it on our website in this thing we call the JSONata exerciser, which is just a web page that allows you to try out expressions. I won't play the video because that's cheating, isn't it? All right, so this is the JSONata exerciser, and let me just zoom in on that a bit. All right, so very simple. We've just got a panel on the left-hand side where we've got some sample input JSON. And then in this little box here, we've got a space to type out our JSONata expression. And the results will get shown down below it there. And we provide some sample data out of the box, for you to play around with, or you can just cut and paste in your own JSON data there. So let's start with really, really simple expressions. Okay, so this has got a very shallow learning curve. We're aiming this at people who are not programmers. We want this to be easy to use. So we've got some data on the left-hand side, which has got some contact details. And our first expression, very, very simple. It's just the name, surname. What does that do? Okay, that picks out the tag there, the item's surname from that object, and it returns the value, Smith. What else have we got? So let's look at address. Now, address is an object. Okay, so it has some structure to it. So just type in address, returns that whole object. But we can carry on down navigating into that using this dot notation. So address.city returns you the city, which is Winchester. Okay, and no surprises here at all. This is what you'll be doing in JavaScript anyway. And so we can extract data. Probably what we want to do is extract several bits of data and combine them in some way. So we've got a set of operators and functions that allow you to combine and manipulate data as well, all within the expression. So let's try first name, and then here we have a concatenation operator. Okay, so we're pulling out two fields now, and we're concatenating them together with a string literal in between them, which is a space. All right, so let's start looking at array data. So phone is an array. Okay, we type in phone and we get the array returned. It's an array of objects. They're all identically formatted objects. They each have a type and a number. So we're interested in the number, or the phone numbers. So let's type dot and type number. And we get all four of them. Okay. Now, this shouldn't surprise you. This is a query language. Okay. So we've said I want all of the phone number. I want all of the items in that document that match phone number. And there's four of them. And it's navigated directly into that array. It's almost ignored the fact that there's an array there as far as the expression is concerned. Okay, so if you did that in JavaScript, that's not the result you get. Okay, if you're interested in just one of the items in the array, then that's fine. We can put an expression in there that just picks out the first one. So we've put an index in there in square brackets, and that's picked out the first one. But actually, if we're dealing with real-world data, that array could be hundreds of items long. And the particular item within that array, we probably don't really know the index. We probably don't even care about the index. What we're really interested in is something else about it. For example, actually, I'm interested in the mobile number. I have no idea where it is in that array. I just want the mobile number. And so I actually want to query that. Okay. And let the engine find it for me. So you might be thinking, well, what's any of this got to do with SQL? Well, it's a very similar concept. Syntax is completely different. But in SQL, if you're familiar with it at all, you'd be doing a select. You'd say select number from phone where type equals mobile. But this is much more aligned to the XPath, XQuery syntax, which is designed for traversing and querying hierarchical data. All right, so let's carry on then and look at something else. So let's look at some other data. So this one, we've got some arrays, and we've got arrays nested within arrays, and we've got a bit more variety in the data types there. We've got a lot of numeric data. So let's have a play around with this. So we can see one of the items we've got here is price. So let's navigate down and select all of the prices of all the products. There we are. So I get an array of 4 numbers. And then I can apply a function. So we've got a function library, and some of our functions are good at aggregating data and the numbers. So we have a function called sum. So we could apply the function sum of that array of 4 numbers and get the total of them. Before we do that, we notice that actually, as well as price, we've got a quantity field in there. And actually, it would be wrong just to sum up the prices, because we'd want to, for each item, for each product, we'd want to multiply the price times the quantity before we did that final sum, wouldn't we? And we can do that. So we can do a little sub-expression at this point, put parentheses around there and say, actually, I want price times quantity. And so each of those values then is the price times quantity for each product. And then I can apply my sum function. To get the final result. Okay, so that's a fairly simple expression that we've built up, we've learnt fairly quickly. You'd have written quite a bit of JavaScript code to do the same thing. So that's one of the benefits of having this sort of declarative query syntax. So we've seen how to navigate a structure, we've seen how to combine values using operators, we've seen a fairly limited set at the moment. We've seen that there are functions, there are a lot more functions than this. One of the other things that you might want to do is actually format the output. Okay, so at the moment I've just created each of these expressions a single value. But actually this is capable of generating arbitrarily complex JSON structures at its output. And so to do that we need to have some syntax that builds arrays and objects. And since JSON already has that syntax in the form of square brackets and braces, then why don't we just use that one? So things like 1.2, 2.3 will actually generate an array. And there's similar, natural JSON syntax for generating objects as well. In fact, JSONata is a superset of JSON in as far that any valid bit of JSON is also a valid JSONata expression which produces that JSON. So I'll show you an example of that. So here I've got some JSON from a REST API. Let's just expand that. Okay, so if you can see the URL there, I'm querying the npm js.org REST service and getting all the download statistics for the JSONata package from npm since the 1st of October last year. Okay, and that's generated this this structure. It's a relatively simple structure, but it's got lots of objects within an array. So let's copy that out. And first of all, I'll just paste it into the JSONata expression window here, just to prove to you that it's quite happy with processing that and generating that as the output. But actually, let's do some more interesting things and put it over here. All right, so we've got this JSON data. And there's this, the thing we're really interested in is this array called downloads. So let's start off looking at that. So downloads. So let's start by transforming that structure into something slightly differently. So let's do dot, and then we'll do our object creation syntax. So at the moment, we're just creating an empty object for every download. So I could do something like, oh, I don't like day, I'd rather call it date. Okay. So now that's going to start populating our output structure. And then I'd rather have count instead of download. Thank you. So it didn't find anything called download, so it just ignored it. Didn't match the query. I did that on purpose. Now the usual rules of JSON exist. The key has to be a string, and it has to be unique. within the object. But in JSONata, it doesn't necessarily have to be a string literal. It could be any expression that generates a string, as long as it generates a unique string. So now I've got an array of objects where the key is the date and the value is the downloads. And since each one is unique, actually it would be nice if I, rather than having an array of objects, I just had a single object with key value pairs here. And the reason that's generating an array is because of this dot operator here. Dot is really a sort of a for each. It's saying for each of my downloads, create whatever we're defining on the right-hand side. For each of my phones, give me the number. It's kind of a glorified for each. So if I get rid of that dot, now I'm just saying, well, within the context of downloads, please create me this structure here, this object. And so now we've got a single object with these name value pairs. These keys have to be unique within a structure. So how does JSONata behave if this expression doesn't generate a unique key? So for example, if we stripped off the day, then we'd have year and month, and then we get a clash. What happens then? Well, we can do that, and we'll see. So there is a function called substring. And so what we'll do is we'll just select the first 7 characters of that day. So we start at character 0 and we select 7 of them. So what it's done here is it's grouped together all of the values that match that key. So in SQL terms, it's done a group by. Okay, it's done some grouping. And it's gathered together all of the values in an array that's associated with that key. Now, we know what we can do with values, numbers in an array. We can aggregate them. So let's use our old sum function again on downloads. And so now what we've got is a transform structure where we've got, the aggregated monthly downloads of JSONata from NPM, okay, since the 1st of October, okay, which we've derived from the daily download information. Now we got other aggregation functions we could have chosen. There's max, which will give you the maximum daily downloads, or average. Okay, let's stick with sum. All right, so the JSONata engine is actually running within the browser. It's not going off to the server at all. Okay, the JSONata engine was designed to be lightweight. I want it to run full stack. It runs in Node.js on the server side, and it runs in the JavaScript engine directly in the browser. So we've seen it running on the browser side. Let's have a look at it running server side in Node.js. You want me to hurry up? Okay, I'll hurry up. So, Node-RED. So we saw this last month. This was demonstrated. What wasn't demonstrated was that Node-RED embeds JSONata. Okay, so let's set up a very simple flow. What we're going to do, we're going to wire together a web server. Okay, so I've got an HTTP get, and let's call it demo. Okay, so what's going to happen is this is going to get triggered whenever we do a GET request into this server. Now, because it's request to reply, we need to do an HTTP response at the end of this flow somewhere. And in the middle, we want to call out and get some data. So I'm going to do an HTTP request. And the thing I'm going to request is this URL here. All right. And that returns a parsed data JSON object. So if I wire these together and deploy that, right, I can drive that using Postman. So here we are, I'm going to localhost 1880/demo. Cannot get demo, why is that? Maybe. Oh, that's a relief. Okay, so that's the data as it comes out of npm.js. So what we're going to do now is we're going to do some processing on there. And rather than writing any JavaScript to do that processing, we're going to use one of the built-in nodes called a change node. Okay, and this just allows you to change something in the message payload. And you can set it to string literals or numbers, or this thing called an expression, which is a JSONata expression. So let's go in there and we'll use this one that we've created here. So we'll just cut and paste that in. Now we do have to modify this slightly within the node red environment. The payload goes into this structure called message.payload. So if we do message.payload.downloads, that should do what we want. And now we'll break this connection and we'll wire the flow to go through that. So I've deployed that. So now, when I do a get, it now evaluates that JSONata expression. Okay, so that's sort of a demo of it working server side. And you can embed that in your Node.js applications as well. Okay, so that's just scratched the surface of the capability of JSONata. It's got a fully functional compute engine within. It's Turing complete. It supports regular expressions and all sorts of other features. Okay, so please do go and have a play around with it.